identifying, we have an altitude has to be at a 90-degree angle, but nothing is necessarily equal, right? So this isn't cutting this side in half. It's just hitting it at 90 degrees. Okay. A median cuts the side in half and comes from the vertex, but it doesn't necessarily split the angle. Okay. The perpendicular bisector is perpendicular and does cut the side in half, but doesn't necessarily hit the vertex. So if you're perpendicular and cutting the side in half, you're a perpendicular bisector. If you're perpendicular but you're not cutting the side in half, you're an altitude. Okay? Now you can be both at the same time, but only in an isosceles or an equilateral triangle. And then here we have no relationship between the two pieces of the side, but the angle's been cut in half, and that's how you know you have the angle bisector. Okay? So median cuts the side in half and is from the vertex. Angle bisector cuts the angle in half, but nothing necessarily else is being cut in half, just the angle. Perpendicular bisector cuts the side in half and is perpendicular, and then an altitude is perpendicular from the vertex. But again, no necessary relationship between anything else. It's just from the vertex and it's perpendicular to the side. Okay, so the next step in this process is that we have to know where what the point is where they intersect, what it's called, because knowing what it's called, then we can learn what it means. So we have to be able to identify the line, and then identify what the intersection is, and then identify what it means to be able to solve these problems. So any questions on these four? Yeah. Yeah, that's a big part of this test, actually, is knowing that it's, even when you have to do some calculations, it requires knowing this first stuff. So that's like the whole test relies on vocabulary, even the calculations, because you have to know what points you're dealing with. Basically, this first page here is like a nice study guide for you. You know, because it's got like the picture to identify, and then it's got the definition, and you know, so hopefully this will really help put it all together. The test is going to be on Tuesday. So the point equally distant from the three vertices of the triangle is the circumcenter. On the circumcenter, right? Yeah. The circumcenter comes from the perpendicular bisectors. So 9 and 7 have a relationship. Equidistant from the three sides of the triangle is the incenter, and the incenter comes from the angle bisectors, right? Yeah, angle bisectors. And that one is number 8. So 10 and 8 have a relationship. And then the centroid is 2 to 1. Remember we did that 1x, 2x thing? and that comes from the medians. So 11 has a relationship with 6. Thank you. Okay. So any question on which lines give you which point and then what each point does? So once you have like the definition part, then you have to actually be able to identify them looking at a picture. And that's where we get to the back of this page. Everybody got this? Oh, which one did you need? B, yeah. Okay. All right. Here's what you look for. In this picture, I have lines coming from the vertex to the other side. Okay, and then those lines are cutting the sides in half. That means I have 3 medians. Okay. So I have 3 medians. What is my point of concurrency where my 3 medians intersect? Medians intersect at the centroid. So this is a centroid. Okay. And what that tells me is if this length right here was 5, this length would be 10. Okay. If this length is x, this length is 2x. That's what a centroid gives us. Okay, but what I looked for was that the lines came from the vertex to the other side, and it split the side in half. Okay. Now on number 13, this one's not going all the way through, but they could go all the way through. So I'm just going to go ahead and extend them. So, because that could appear in a picture, and I want you guys to be able to identify that too. Okay. So what I'm looking for on this one is when I look at this, okay, I've got a line coming from a vertex. I don't have anything happening with the sides at all. Nothing's marked, but I have these angles that are being marked as equal. And I've got 3 of those. So this comes from a vertex, and I have equal angles. This comes from a vertex, and I have equal angles. Not medians. If I'm cutting the angle in half, I'm an angle bisector. So I have 3 angle bisectors. The corners, yeah. Yeah. Okay. So I have 3 angle bisectors, and my 3 angle bisectors intersect at the incenter. Okay. And what my incenter tells me is that these lengths here are all the same. So if this one's x, and this one's x. That's why I continued those out. Okay. Now when I look at this picture, I'm seeing that these 3 lengths are the same. So the length from the vertex to the point is the same. Since these 3 lengths are the same, Patrick, sorry. since these three lengths are the same, that tells me I'm dealing with a circumcenter, and that what I have are three perpendicular bisectors. Now, they weren't marked, but if I did continue these out like this, they would be perpendicular. Oh, sorry, that should have gone like that. Okay. Obviously, this triangle is not drawn properly, but you get the idea. So the circumcenter and the perpendicular bisectors mean that those are the same here and here. This length would be the same as this length, and this length would be the same as that length if this were drawn to scale. And that these three lengths are the same. So if this was y, this is y, and that's y. The what? No, the circumcenter is from the perpendicular bisectors. So it doesn't have anything to do with the angles. It's that the line coming down is perpendicular to the side. And then all your distances from the vertices are the same. Okay. Number 15, you see we have perpendicular. So we've got these three perpendiculars. And these lines. So what I have is I have three lines that are cutting the side in half, and they're perpendicular. So these are perpendicular bisectors. And they meet at the circumcenter. And because I'm a circumcenter, that would tell me that this length is the same as this length, is the same as that length. Okay. Now the difference between number 15 and 16, because they're both got perpendicular, right? But you see how this has no markings for the sides? That means that what I have are altitudes. The altitude goes from the vertex perpendicular to the other side, but it doesn't have a relationship between the lengths of the side. Like, it doesn't cut the side in half or anything. So that's the difference there. So what you see when you see 90-degree angles, like perpendicular lines, you look for those marks. If you have those marks, you're a perpendicular bisector, so you get the circumcenter. If you don't have those marks, you're altitudes. And the altitudes intersect at the orthocenter. And the orthocenter doesn't do anything. It's just there. There's no relationship between any of the lengths or angles or anything like that. It's just, they gave it a name. Questions so far? Now this one also has perpendicular, but what we have is these lengths that are the same. Do you see that? So what this is telling me is the distance to each side is equal. Okay, because distance is always perpendicular to, like, so if y'all wanted to measure the distance between like say me and Sarah, we would make a line from me and like going this way and a line from Sarah going that way, and we'd measure the perpendicular line between us. That's how distance works. So what we have is that these three side lengths to the side are equally distant, and anything that's equally distant to the side is an end center. And what that would tell me is if I continued these lines up and down like this, because it's an end center, that would tell me that this angle would be equal to that angle, this one would be that one, and this one would be equal to this one. And then I have sides that are cut in half. So if I have three perpendicular lines that are cutting sides in half, I have three perpendicular bisectors, which makes this point the circumcenter. Okay. And again, with the way this is drawn, I don't have the lines that are equal to that, but the circumcenter is equally distant from each vertex. So if I came in and I drew a line to the vertex, like this, those three blue lines would be equal length. So the circumcenter doesn't have to be inside the triangle. Actually, the circumcenter, write it down here. The circumcenter and the orthocenter can be outside. The end center and the centroid have to be inside. And that's due to the nature of the lines that create them. Okay, and then I drew that thing up here with the circles. If the triangle has the circle inside of it, and then the center of the circle is inside, this is the end center. See, it's in the center. In. And if the triangle is drawn and the circle is outside the triangle, it's the circumcenter because we have a circumference. So let's start with this. DG, EH, and FI are all medians. And medians meet at the centroid. So this point right here is a centroid. Okay, and the centroid gives us that 2-to-1 thing. Okay? So if that's x, this is 2x. If this is y, this is 2y. If this is z, this is 2z. Okay? This length is twice this length. So I want to find FG. If GE is 8. Well, okay. What else do we know about medians? Anybody? They cut the sides in half. So this length is the same as that length. This length is the same as this length. And this length is the same as this length. So if FG, we're trying to find FG, well, GE is 8. So what does that make FG? 8. These two are the same because this side is being cut in half. So FG is 8. Okay, now DH, if DF, so this whole length, DF, is 10. And I want to find this part of it. Well, the median cuts it in half, so that would make it 5. And then DI, I guess we're just doing sides. DI is 7. So then what's DE, the whole thing? 14. Yeah. Okay, this one we're going to be using the centroid. Okay, we've got medians again, so we've got a centroid. Okay. I want to find xn, that's this length here, if kx is 26. And that's this length here. Since we have a centroid, if this was x, this is going to be 2x. So if this part is 26 and it's twice that part, we get 13. Jx if xm is 25. Well, xm, that's this length right here, is 25. I want to find this length right there. If that's y, then this is 2 times y. Apparently this pen doesn't like to write on top of highlighter. Okay, so if this is 25, what's this one? Okay, so the part from the vertex is always going to be the longer part. Now I have Lx is 41. That's this line right here, 41. What's this part, the short part? Yeah, 20.5. So I have to do 41 divided by 2, so I get 20.5. Okay, these you'll do for homework. 7, 8 through 10. And then we'll flip over to the back. And we have angle bisectors. Okay, if I tell you that these are angle bisectors, what does that tell you about 1 and 2? If this is an angle bisector, what are 1 and 2? They're the same. And 3 and 4 are the same. So if angle 2 is 36, what is EDF? That's this whole thing. Well, if this part's 36, then that part's also 36. So we double it. If angle EFD, so this whole thing, is 68, what's angle 4? Well, angle 4 is half of it. So angle 4 would be 34. I want to know what EDF is, so that's this angle right here. If angle 1 is 27, what's the whole thing? Close. 54. And then finally, if angle 4 is 23, what's angle 3? Well, this has been bisected, so angle 4 and angle 3 are the same. So if angle 4 is 23, angle 3 is also 23. And I want you guys to do 5 through 9 for homework. What they just said it was 23. They're saying if it is 23. Yeah. And 4 and 3 would be the same because it's being bisected, and so it's cut in half, so they're equal halves.
Is all the bottom parts on there?
Yep. And I did not get you guys enough practice on using the centroids. So what we're going to do now is let me find some problems that I like. Not ultrasound. Yeah. Let's look at 1 and 2 on here. So I'd like you guys to try 1 and 2 on here. And then we'll go over it together. Okay, so it's a centroid, so that tells us about the measures. What is it? No. This is the centroid, so this is that, hold on, let me draw one real quick. That's this situation where you have the short side is 1 and the long side is 2. So PC is the long side. And PF is the short side. And so the short side is one of them. So 6 is 1. I need 2 of those over here. So you multiply by 2. Does that make sense? Altogether, it's broken into 3 pieces. Like if this is this line right here, I have an X. It's been broken into 3 pieces with the centroid there. This is one of them. This is 2 of them. So it's like 2 of the pieces. So the short piece is a single piece. The short side to the side is a single piece, and then this is 2 pieces. So if the one piece is 6, 2 pieces would be 12. Yeah. Okay. So did everybody get that? This one's 12, number 1. Okay, for number 2, they gave us the whole thing. And they told us that the whole thing is 15. Well, I need to break that into 3 pieces. So I divide 15 by 3 and I get 5. So this little piece is going to be 5. And then this long piece is going to be 10. So my answers were 12 and 10. Did everybody get that? We talked about the angles. And if I'm bisecting an angle, that means these lengths are the same. So just to review that really quickly. So if this one's 8, what is that one? Okay. And then if these match, that means if this angle is 23, what is this one? 23. Okay. And then when we got to this part, if these two were the same, that meant these two were the same. Do you remember that? So if those are both 10, that means 2x minus 4 is equal to x plus 5. So I could solve for x. So I subtract x from both sides, and I get x minus 4 is equal to 5. I add 4 to both sides, and I get x equals 9. But I'm not trying to find x, I'm trying to find NP. And the NP is x plus 5. So 9 plus 5, so 14. Everybody okay with those problems? Yes, no, maybe? Okay. Try 10 through 14. Does anybody need me to go over any of them? Yeah. Which one? Or any of them? Okay. So what I've got, whenever these two match, these two match. So on this one I didn't have to do anything other than it's 9 here, so it's 9 there. Okay. Whenever these two match, that means this and this side match. Well, if the whole thing is 12, it's being broken in half, so this is 6 and this is 6. So that's where that one came from. Okay. Over here, they wanted EG, which is the whole thing. But because this and this match, that means this one and this one match, so that's 5 and that's 5. So it's 10, because it's the whole thing. And then here, this one was 4, so that one's 4, because these match. And then on this one, because these match, that means those two match. So that's where I had to do some work. I set 4x minus 4 equal to 2x plus 12. Then I solved for x. X was 3. But they didn't want x, they wanted SW. And SW is this whole thing. Well, I plugged the 3 into here because it was easier. So 2 times 3 plus 2 is 8. So that meant this is 8, but these two match, so this is also 8. So the whole thing is 16. Which one? That one was 9, so this one was 9. So if these match, these match. Oh, NP, we did that one here. Because these two match, that means these two match, so I set them equal to each other and solved it, and I got 9 for x. And then I wanted to know NP, which is this length here. So I plugged in the 9 and did 9 plus 5 to get the 14. Okay? Okay, so